Bismillahirrahmanirrahim. Dear students, today we are going to discuss exercise 2.4. Question number 1. It is given that ax square plus bx plus c equals to 0 and alpha and beta are the roots of the given equation. So we will have to find alpha cube beta plus beta cube alpha. Solution. Take alpha beta common. Here remains alpha square plus beta square. Now add 2 alpha beta and subtract. Alpha square plus beta square plus 2 alpha beta minus 2 alpha beta. Why we add 2 alpha beta and subtract 2 alpha beta? To become these terms are perfect square. So we get alpha plus beta whole square minus 2 alpha beta. Look here. Alpha plus beta a x square plus bx plus c equals to 0. So here the a value is a, the b value is b, and the c value is c. So alpha and alpha beta are the roots of the given equation. So we can write it here that sum of roots, which is alpha plus beta, equals to minus b by a, and product of roots, which is alpha beta, equals to c by a. We will put here, or look at here. Alpha beta is the product of root, which equals to c by a, and alpha plus beta is the sum of root, which equals to minus b by a square, and minus 2 here c by a. Now c by a, here minus b square minus b, so the minus sign will be change into plus because the exponent of b by a minus b by a is even. So b square by a square minus 2c divided by a. Now take a square, the LCM. Here is a square and here is a. So the LCM will be the term having greater exponent. So a square is the LCM. B square we will write on its place, and when we multiply a with a, it become a square, so it will become 2ac. Further you can multiply this a here. C b square minus 2ac divided by a cube. I think it is the book answer. Part 2, alpha minus beta whole square. Expand this. Alpha square plus beta square minus 2 alpha beta. Now add 2 alpha beta and subtract. Alpha square plus beta square 2 alpha beta minus 2 alpha beta, and this minus 2 alpha beta on its place. Now it becomes alpha plus beta whole square minus 2 and minus 2 minus 4 alpha beta. So sum of roots, which equals to minus b by a, and product of roots, which is equal to c by a. So here we get b square by a square and minus 4c divided by a. Take a square, the LCM. We get here b square minus 4ac, the answer. A into a we get a square, so multiply that a with the 4c, which is the answer. Question number 2 is very interesting. We will have to find the equation whose roots are these two. These. So part first, solution 1 and 1 by 2 are the roots. So first we will find sum of roots represented by S. Sum of roots 1 plus 1 over 2. So we get 2 ones are 2 plus 1 divided by 2. Take the LCM 2. So here we get 3 by 2. And product of roots by P, which equals to 1 into 1 over 2. So P equals to 1 over 2. Now the required equation will be of the form x square minus sx plus p equals to 0. So put the value of s and p here. X square minus s value is 3 by 2x and p value is 1 by 2 equals to 0. Multiply the equation, all the terms on both sides by 2. So we 2 into x square minus 2 into 3 by 2x plus 2 into 1 by 2 equals to 0. These two cancel with this and this cancel with this. 2x square minus 3x plus 1 equals to 0. This is the equation whose roots are 1 and 1 by 2. So in the previous chapter first, the equation will be given and we will have to find the roots. Now here the roots are given and we are going to find the equation whose roots are these. How we know this formula? From where? So look, if you remember the standard form of quadratic equation, which is ax square plus bx plus c equals to 0. Now divide all the terms on both sides by a. So we get ax square divided by a plus b by ax plus c by a equals to 0. This a cancel with this. So we get x square. Now split this plus into 2 minus. So we can write it as minus into minus b by ax and c by a equals to 0. When this minus multiply with this, so we get the plus again. Now x square minus b by a is what? The sum of roots. So use the capital S or S for this, and c by a is the product of roots. This is the required form of finding an equation when the roots are given. So similarly in the second part, the roots are minus 3 and 4. Solution. So s equals to minus 3 plus 4, we get 1, and p equals to minus 3 into 4, we get minus 12. The required equation will be x square minus sx plus p equals to 0. Put the values here. X square minus s value is 1x and the p value is minus 12 equals to 0. So we get x square minus x minus 12 equals to 0. The required answer. Part third. So here the roots are 3 plus under root 2 and 3 minus under root 2. So you can also, when you look at the example in the book, so it is by this method. Sum of roots equals to, add these two, 3 plus under root 2 plus 3 minus under root 2. These two cancel, we get 6, and product of roots which equals to 3 plus under root 2 into 3 minus under root 2. Now this is a plus b and a minus b form. A square minus b square. Here we get 9 minus 2, 7. The required equation will be the required equation will be x square minus, here sum of roots into x plus here product of roots equals to 0. Put the values here. X square minus sum of root value is 6x and the p value is 7 equals to 0. So you can also solve it like this, or you can use sx and plus p with, as I did it in the first two parts. Part 4 is your homework. Try it.